Hi, Ivy. We're going to go ahead and continue with arithmetic sequences and go a little bit further in detail with them throughout 6C. So just remember our discussion about a sequence. You're looking for a pattern, and with an arithmetic sequence, it's an arithmetic progression. So remember, arithmetic means you have a common difference. So we're looking for that common difference between each of our terms in our sequence. So if we look at our example of 4, 6, 8, 10, we'll notice that from 4 to 6, we add 2. From 6 to 8, we add 2. So we already can tell that we have a common difference of positive 2 as we move from one term to the next. However, if we wanted to prove that, we just would kind of work our way backwards. So we could say, all right, well, the difference between 10 and 8 is 2. And the difference from 8 to 6 is 2, and that's already enough to prove, but let's go ahead and do one more. 6 to 4 is 2. So we have a common difference, and we'll call that D is equal to 2. So just taking a look at some of your notation, especially from your textbook, U sub n is just referring to one term in your sequence, and U sub n is arithmetic. Well, U sub n is representing any term in your sequence because n is any positive value. So, for example, if you have one term, n plus 1, minus the term before it, which is U sub n, then you should have a common difference. So up in the example, U sub n plus 1 might have been our 8, and then we subtracted it from the term before it, which is 6, and we have a common difference of 2. All right, so our sequence is arithmetic. So these are all of our terms in our sequence. N can represent any value, right? So for example, let's go back up to the 4, 6, 8, 10 sequence. This might have been U sub 1, U sub 2, U sub 3, U sub 4. So U sub n is just going to represent any term in that sequence. And if we subtract them, we have a common difference, then we can prove that it's arithmetic. So it's only arithmetic. This symbol right here, the double arrow, means if and only if. So it's arithmetic if and only if you do actually have that difference between them. You can subtract them and find that common difference. All right? And these two values here, U sub n plus 1, U sub n, since they are terms within the sequence, these are called consecutive terms. Okay? One right after the other. So working through these two examples, this would be a great time to pause and try these on your own. So if you were given U sub 1, U sub 2, U sub 3, U sub 4, U sub 5, U sub 6, and so on, if you were given all of these values, all these terms in the sequence, how can we actually show that they are arithmetic sequences? All right? So thinking back to that same process before, we could take U sub 6 minus U sub 5, which would be negative 5 minus negative 2. Be careful with your arithmetic here. All right, negative 5 plus 2, so negative 3. And then we've got, let's take U sub 4 minus U sub 3. So that'd be 1 minus 4, we get negative 3. So already we have a common difference of negative 3. So yes, it is arithmetic. And this second example, we're given an expression to evaluate our different terms in our sequence. So for example, U sub 1 would be 2 times 1 minus 3. So 2 minus 3 gives you negative 1. U sub 2 would be 2 times 2 minus 3. So that would be 4 minus 3, which is positive 1. Let's go ahead and find U sub 3 and U sub 4. So 2 times 3 minus 3, and 2 times 4 minus 3. So we get 3, and we get 5. All right, so already we can probably see the pattern, but again, since we want to show, that word show means we need to prove it slightly. So let's go ahead and take U sub 2 minus U sub 1, which equals 1 minus negative 1, which is a difference of 2. And let's take U sub 4 minus u sub 3. It could have also been u sub 3 minus u sub 2. You guys have your options. So 5 minus 3, which also gives 2. So we have that common difference of positive 2 again, all right, as we did earlier in our first example. So guys, think of this one application here for arithmetic means, all right? If you have 3 values in a row, so these could be any 3 values, any consecutive terms. So if you think of any arithmetic sequence, I could even just use something as simple as 1, 2, and 3. If we call those our A, our B, and our C, now you guys have been doing means for a long time. If I took 1 and 3, how would I get 2, right? Or how would I start with 1 and get to 2, or 2 and get to 3? So think about how those 3 values are related for a moment. We just discussed that if you found the difference between the next one and the one before it, so C minus D, it should be equal to B minus A. So if I just rearrange this slightly, let's move our B's onto the same side. So if I add B to the right, I'll have 2 B's on the right. If I add A to the left, I'll have C plus A. And then if I isolate B, I'll have C plus A and divide by 2. So what you just did was you took your first and your third value, divide by 2, so you're finding the average, and you're getting that middle value of B. So this right here is called your arithmetic mean, all right? Just another way of looking at that arithmetic sequence and making sense of your values. So therefore, in the future, if you're given a question where maybe we don't know every term, or you're trying to find a middle term, or you're trying to figure out what the pattern is, this is another way that you guys can approach the question. So far in these notes today, make sure we have one formula written down as your arithmetic mean. And our second formula we're going to be wanting to write down in a moment is called your general term. So we mentioned before, you're not going to want to continue this pattern if the question asks you to find the 100th term, right? So if you were going to keep going out to 100, to the 100th term, this would take you a long time by hand. So let's see if we can generalize and try to come up with a little quicker way. So your u sub 1 is 4. Let's go ahead and look at the relationship to u sub 2. So u sub 2 is 6, which is really just coming from 4 plus 2. U sub 3 is 8, which is coming from 4 plus 2 twice, right? U sub 4 is 10, which is coming from 4 plus 2 plus 2 plus 2, 3 times now, because I'm now on the 4th term. So think about that. If I'm on my 4th term, I've had to add 2 3 times. On my 3rd term, I had to add 2 twice. On my 2nd term, I had to add 2 once. So what's really happening here is I have my first term, and then I have 3 multiplied by my difference of 2, right? So I have 3 2's. Wherever you put your brackets. So 4 plus 3 times 2. So if we generalize this, what you're really looking at is your first term, which we'll call your first term, u sub 1, and we're adding on your difference, which is 2, and we're multiplying that by 1 less than the term that we're at. So we got this 3 because it was 1 less than 4. All right, and if we look at the earlier example, we had 4, and then we had 2 times 2, okay? So this 2 is our common difference, but this 2 came from being 1 less than 3, and so on and so forth. If I went back again, here's my first term, and I only have 1, 2 that I need to add on, okay? And that's 1 less than this 2, where I'm sitting on my sequence, okay? So that would be our n minus 1. So looking down at your general term, second formula we need to make sure we have down today is that general term. All right, so we'll call this formula number 2. So if you guys have any value, you can always add the difference on. Your book shows you can add it on once, twice, 3 times. That'll just continue for however many terms you have in your sequence. So let's just generalize it and say that we're going to multiply your difference, d, by n minus 1. And then we'll just add it on to that first term that you had in your sequence. All right? So just being familiar with notation Your u sub n is any general term in your sequence. U sub 1 is your first term. N is the position that you are on at the moment in your sequence, and D is your difference. So 2 formulas today that we need to be familiar with. So let's just revise what we should be able to do now at this point. I would like you guys to try this one on your own. So when you guys come to class next time, we can go through this together. But notice the sequence that you're given. The first step says show that it's arithmetic. So again, we want to think of this as our u sub 1, u sub 2, u sub 3, u sub 4, u sub 5. And we want to show that there is a common difference. So for step A, you want to show that there is a common difference. And that is what we were doing in the first example that we began with today. So try that one on your own. In section B, it says find the formula for its general term. So that means our general term formula is always our first term, adding on to n minus 1, multiplied by our common difference. So if we now know our common difference from part A of this question, and we know our first term because we're given our sequence, what would this general term formula look like? All right, so if you can set that up as well. For part C, find the 50th term. So if I now have a general term from part B, can I find the 50th term? What will that look like? Part D is asking, is 325 a member? So 325, they're asking, if you continue the sequence, would you ever actually get to 325? Well, if I want to know if I'm going to get to 325, I want to know if 325 is an actual term. And since we don't know exactly what term it is, we are going to let it be the left-hand side of our general term formula. So if I start with my first term, and I continue to add on n minus 1 with a common difference, so we'll know this value, and we know this value, can we figure out an n value that will actually give us 325? And similarly, is 761 a member as well? So see if you guys can pull together a couple of things we talked about and work your way through these 5 sections. All right, have a good night. We'll see you guys soon.